Hello, Mr. Foley here, and I'm going to talk about basic fraction addition. In class, I've mentioned several times that adding and subtracting fractions is more difficult than multiplying fractions. And it's true, it's a little bit complicated, um, specifically when we have unlike denominators. So let's jump into this. We have two diagrams here on the screen. And on the left, we see 1 out of 3 shaded. So this would represent 1/3. And on the right, we have 1 shaded out of 4. So that would represent 1/4. Now, if I want to add these two together, I have a problem. And the problem is I have unlike denominators. I can't add thirds and fourths, right? In class, I often say you can't have apples to oranges, right? I always say that. We can't add apples and oranges. We need them both to be apples to add them. And so that's really the problem. We have to do something. And there's two methods we talked about doing to take care of this. So let's look at this 1/3 plus 1/4. So that's our problem. Let me rewrite it here. We're trying to add 1/3 plus 1/4. So we talked about two ways. One way, and again, it may be a little confusing, we got to practice, but one way that I showed you was to using letters to represent the fractions. We said a over b plus c over d could be thought of as this. On the denominator, we multiply the denominators together like this, b times d. And then on the numerator, it's a little confusing. We got to use parentheses because we got a little bit of work to do here. We're going to do a times d, and then we're going to add to that or subtract. If this was subtraction, I would subtract. But whatever the operation is here, you're going to do the same operation here. And then another parenthesis, and this will be b times c. And all of that will give you the answer. So if I was to use that method with 1/3 plus 1/4, it would look like this. The denominator would be 3 times 4. And then what I like to do, just to kind of make things a little easier, I make a line going diagonally this way, and I look at the 4 and the 1. 4 times 1 is 4. I always write the 4, and I circle it. That's just a method that I use. Then going the other direction, this is, so 4 times 1 would be the a times d, right? And then the 3 times 1 would be the b times c. So 3 times 1 is 3, and again, I write it and circle it. I hope that comes on the screen because I think I'm just about out of my viewing area. Then I always remind you to check your operation. If you're subtracting, subtract. If you're adding, then you add, okay? So that makes this 4 plus 3. And then put it all together for your final answer. You're going to have 7/12. And so that's one way of doing this type of problem, 1/3 plus 1/4. Now the other way is to rewrite each fraction, each term, into like denominators. And so the way that I showed you to do this, I always say that I like to write this in a vertical fashion, 1/3, 1/4 above each other over the top, right, like this. And the reason I like to do that is because I have to rewrite these into equivalent fractions. And I need to figure out what is the denominator. And the way we do this is by finding LCM for least common multiple, or we call it LCD for least common denominator. So the way we do that is we do multiple, skip count 3, skip count 4, find the number that's smallest that they both have in common. So we would go 3, 6, 9, 12, 15, and you go a ways and then stop. Hopefully you don't have to go that far before you find it. 4 will be 4, 8, 12, 16, and so you should see we have our LCM and it's 12 right here. So we'll circle it. That's it right there. That's the LCM or LCD. So what that tells me is I'm going to make both of these denominators 12. This will make like denominators. And now, how do we find our numerators? Well, this is what we do. take each one in isolation. Don't the 1/3 we work separately, and then the 1/4 we work separately. So we think, what could I multiply times the 3 that would equal 12? And you should know that's 4. 3 times 4 equals 12. And that means I have to do exactly the same thing in the numerator. If I don't, I'll have a wrong answer, so you want to make sure you do exactly the same thing for each fraction. So for this one, I'm doing 4. And then 1 times 4 tells me that the numerator is a 4. So we're saying 1/3 can be rewritten as an equivalent fraction, and it equals 4/12. So it's still a third, it's just written in a different way. Now we'll look at the 1/4, and we do the same, we repeat the same thing. So again, what could I multiply times 4 that gives me 12? And you should know that that's 3. And if I do it to the denominator, I must do it exactly the same with the numerator, and 1 times 3 gives me 3. And so what that does for us is, now that we're adding like denominators, they're 12ths, our answer is going to be 12ths. And now we just have to add the numerators, 4 plus 3, and we get 7. So that's another method. And if I go back a page here, you'll see we had the same answer, 7/12 right here. Okay. Now, if I go back one more time here to our original problem, another way to do this, or see it, is if I broke this third into 4 pieces. So I could do that by breaking it in half. First, let me make that line a little thicker so that you can see it. So if I make it into 4, so I go half first, then I'm going to make each half in half, right? Now that third is broken into 4 pieces. Okay, and I could do it on these other pieces here. It wouldn't really matter. It doesn't make a difference. But, well, actually, I should show it, because what this is going to do is it's going to make this third into 12ths. Notice there are now 4 12ths there. So what we did, we just showed that 1/3 could be rewritten now as see 1, 2, 3, 4 12ths, or 12 now, all the way split apart, 12 parts, 4 are shaded. So we could say it's 4 12ths. That's what we got when we rewrote our fractions, if you remember. On the right, if I break these into thirds, so now I'm going to break these into thirds. Oh, something happened to my, everything was, oh, here we go. Everything was going so well. So I'm going to go to thirds. I had a little problem there with something. And then I could break these also into thirds. And again, this is going to create 12 parts total of the whole. And now I have 3 of them shaded of the 12. So what I'll do now is I'll show that this 1/4 could be rewritten as 1, 2, 3. See, 1, 2, 3 12ths. So 3 12ths. Okay. And now if we want to add them all together, basically you got 4 plus the 3, and altogether that's 7 12ths altogether. So just another way of looking at it. So hopefully that helps out a little bit. Those are a couple of different ways of looking at it. Again, practice and you'll get better at it, but that's how we do it. Thank you and have a great day.